Alright, hello, my name is Mateo Rico and I'm making this video because I couldn't find this information, so I figured I'd figure it out on my own. It's nothing too difficult, but I wanted to share it with you guys just in case someone needed help. 3D printing and rapid prototyping tolerances, more specifically tolerances for the Ender 3. So to begin, let's talk about what rapid prototyping is. Rapid prototyping refers to the process of quickly creating a physical prototype or model of a design using a 3D printing technology. This allows designers such as yourself and engineers to test and refine their designs before committing to a full-scale production. Now, this is a common misconception or like a flaw within the 3D printing community that in a sense you can hit print and your print's going to come out perfect. For the most part, you have to print multiple times to actually get something good. But that doesn't mean you also have to print your full-scale object every single time to determine whether it's going to be good or not. And that's the idea of rapid prototyping. You can print out and slice certain segments so you can do a 1 hour, 2 hour print to figure out how the dimensions for that one piece are going to work, as opposed to printing some 16-hour print only to find out that that one segment didn't work. That's the idea of rapid prototyping. And to further expand on this, with the Ender 3 printing, you can quickly iterate on your designs and then test them for fit, function, and aesthetics. Again, just following up with what I was saying. Skipping all that to say that it saves time, money, and materials. So a lot of times you see that it's gonna be a 16-hour print. You put it in the printer, you could have saved yourself a lot of time by testing out 1 hour, 2 hour prints to make sure everything was gonna fit together from the beginning. In this video, I'm going to be showing you how I dimension different screws and different accessories to make different 3D printing parts. This part of the process would always hold me back from printing because I didn't know certain parts. It wasn't fun. It wasn't the fun part of 3D printing and designing. So it always held me back, but I put it upon myself to figure out all these dimensions so that I would know these numbers going in. So in order to follow along, or at least with what I'm using in this video, I'm using the Ender 3. The software I'm using is SolidWorks. I have it because I am a student, but I understand, I've never used it, but from running it, I understand Fusion 360 works just as well. The hardware I'm going to be dimensionalizing are M2, M3, M4 screws, some screw and bolts, and some different accessories. To specify, I'm going to be using the Crocs Gibbets accessory, so I can 3D print some gibbets and put them on my Crocs. I'm going to be 3D printing a flat back to attach to pins that I can attach to my clothes, yada, yada, yada. And the tools you're going to be needing in order to actually come up with good dimensions and tolerances are going to be calipers and a notebook. So here's a little video on what I'm going to be measuring. From left to right, we have the M2 screw, we have the M3, M4, and different sizes and variations of screw and accessories. This is some grip tape, not like your skateboard grip tape, but kind of like a duct tape material, so I can make 3D printed parts that attach to something with compression and stays on there as opposed to sliding down because it's plastic. This is a magnet, so I'm going to be coming up with the dimensions for this magnet. This is the pin I was talking about. Just kidding. This is the Croc gibbet back. So that Croc part connects into the Croc itself. And I bought this specifically so it wouldn't break. I felt that if I were to 3D printing, it'd be prone to breaking. So my idea is to just glue it on top as opposed to 3D printing that back part every time. Not saying that it's not possible. I just feel like it'd be stronger if it was a bought part that's already fabricated and it injection molded as opposed to 3D printing. 3D printing should work, but I just feel like this isn't gonna break. And there's the magnet to make magnets as well. Following up on this video. So the notes I took with respect to all those different objects I showed you for dimensions are the diameters of the heads, the heights of the heads, the lengths of certain bolts of the tape, with just different dimensions you want to keep in mind when measuring all the objects for tolerance factors. According to a forum I read up on, a general rule of thumb is to use 0.2, oh, there's a bug around here, 0.2 millimeters of edge to get these items to fit, and those are the numbers that I used. Here is the link. And so to further expand on that, let's say that this M2 bolt, M3, M4, whatever, these are the dimensions I got. I got the dimensions of, I got the diameter of the head, I got the height of the head, and I got the diameter of the I call it the stem. I don't know what the technical name is for this thread, but I call it the stem. And I wasn't too worried about the height because I have a lot of different varying heights for the stem, and I figured that as long as I have a general sense of what the hole is, I can find what screw is going to fit it. So the height of it wasn't too much of my worry, right? So these are where, so let's say we're going to 3D print a hole to fit this thread. This orange outer diameter has to fit the largest diameter of the head. The purple diameter on the bottom has to fit the stem, and then we have the counter bore for how deep the head should go in order to fit all of this, which gives us, again, to further explain how the 0.2 millimeter works, because this was the part of the dimensioning and tolerances that I had trouble with. So we measure our diameter of our head, and we get our actual diameter. So let's say I measured this diameter of this screw and I got 3.2 millimeters. That means that I need 2.2 millimeters on the left-hand side and 0.2 millimeters on the right-hand side in order to fit that object according to what was said in the forum. So you want 2 millimeters leeway on 0.2 millimeters leeway on each side in order to fit it well, which were the numbers I used. So here's some of the math. We would take the diameter of the head, add 0.2 millimeters to each side, which would give us, from the original number of 3.2, we would add 0.2 and 0.2 and get 3.6. So those are how I managed to get the numbers. If you can see here, I didn't add 0.2 twice, I only added it once because it's not with respect to two sides of the head. The head only goes down, and so in that aspect, I would only need that leeway going down. I wouldn't need it going up because I would want it flushed. So that's how I came up with the numbers, and at that point I basically just went at it with the calipers. I have my set of calipers right here. I bought this on Amazon, pretty cheap. I don't recommend them because the battery's already blown out and I barely even used it. But regardless, I would go in with every single object. Here you can see all the different dimensions that I needed with respect to every screw that I measured. This is the M3, yeah, this is the M3 hex. So I took the M3 hex. I would take my hex, if you can see it, it's a little hard, but let's put it on the calipers. We put it there. And that's the dimension I got, right? So, which reads roughly about 6 point something according to the calipers. So I did that to basically get all of the dimensions I needed in order to go into the 3D modeling software and model those. With the Breeze, not necessarily focused or measuring as I go. I just wanted everything on one sheet, just ready to plug and play. So these are all the M screws, these are the wall screws, here are the accessories. So this is the crock gibbet. So again, another example would be that I measured the base of the crock gibbet and I got 10 millimeters, and then I added 0.2 millimeters to each side, and I did that basically for all of the different accessories as well. Here is the final print that I ended up with. So here's from left to right, the M2, the M3, and the M4 screws. For the most part, everything fit pretty well, except the stem hole. So where the hole goes into the smaller hole for these different threads, they tended to be a little small. I think I'm gonna add either 0.1 or 0.2, just a tiny bit to get that edge on it. But aside from that, they all came out pretty well. I'm pretty happy with the results. The head on the M2 screw could have gone a little deeper, which is another way I could fix that and further adjust it. If you can see here, I zoom into this part, and for this, I'm drawing a blank. For this washer tended to be a little on the smaller side as opposed to the hole that I made. I don't know if I made it a typing error, but that's something I need to fix, because according to how it sits here, it's not flushed the same way I want it to. Also, the height of it is too thick. It should be able to just stay flushed and straight with the print. Here you can see how this middle one ended up being perfect. So those dimensions, aside from the thread hole, which I want to make a little bit bigger, came out well. The larger screw and the smaller screw both tend to stick out a little bit, which is not what I want for my design. I want it to sit flushed perfectly on the face of the print. So those are little slight adjustments I need to make, nothing too harsh now that I have a starting point. There's the gibbet. The gibbet came out perfectly. Just using the numbers that I had. The grip tape, again, it came out perfectly with respect to the numbers I originally intended. The magnet sits perfectly in the hole. I'm not too worried about making it fit perfectly, only because I plan on using super glue if I'm gonna be doing magnet stuff. And the paper, or the pin clip, it sits on there. I could make it smaller, but I think that's good enough for what I plan on doing. Let's skip on over testing. So in order to test all these different numbers, you want to ensure that your printer is tuned to the most common settings that you're going to be using to ensure accuracy over time. I personally have my Ender 3 printer and I don't have it modded. I don't add all that fun fancy stuff to it because I like it stuck. You know, it's good to do what it is. I don't need to make it blown out to make crazy stuff. You know, I have a resin printer who I would like to make like my crazier stuff with on the resin printer, as opposed to jeopardizing my Ender 3 when it's perfect as is. My other note says, once print is complete, test and ensure all parts fit accordingly. If not, make sure to adjust tolerances by 0.2 millimeters until 3D print meets desired requirements. And to wrap this video on up, as boring as this process may seem, it can expedite the long-term creative process by creating a more efficient workflow, and it's definitely worth the time investment. 3D printing and rapid prototyping is commonly thought to be the final product, when in reality, a good design should take 3 or more iterations to make it come out exactly how you want. Another point to point out would be print orientation. For the most part, I printed all my prints flat on the bed plate, but if I'm gonna be adding different thread screws and the print orientation tends to stand vertically as opposed to parallel with the build plate, that can alter and change certain dimensions. With that said, that basically wraps up my presentation on tolerances. If you have any questions or would need any help, I would be more than happy to help you out. I do plan on coming out with more 3D printing content, but my page or my channel is scattered all over the place. I like to do music stuff. I like to do adventure stuff. So if you could, please consider subscribing, as I want to blow up as a YouTuber. Thank you for your time. Adios.